you. Hey, everybody. I don't know about you, but I've been eating a lot of comfort food lately and watching a lot of comfort TV. And my favorite comfort TV is the show Parks and Recreation. Now, one of the things that makes the show so amazing is the characters. And I want to introduce you to Ron Swanson. Now, Ron is kind of an old school guy. He's a bit set in his ways. He likes his privacy and he likes to stay off the grid. Now, in season 6, episode 14, Ron discovers Yelp. He loves the idea of being able to review places he's been. However, Yelp is way too on the grid for Ron. So Ron uses the internet to look up the physical addresses of where he wants to snail mail his reviews, and then he pulls out his big old typewriter, puts it on his desk, and starts typing out his reviews. Now, Ron writes some pretty great reviews. Here's one of my favorites. Dear frozen yogurt, you are the celery of desserts. Be ice cream or be nothing. 0 stars. Now, this is a pretty great review, but I see 3 problems with this approach. First, snail mail is way slower than posting the review to Yelp, where it will be instantly available. 2, the businesses he's reviewing may never open the review because they may just assume that it's junk mail. And 3, no one else is going to benefit from the review. I don't know about you, but I live for these kinds of reviews on Amazon. So Ron was inspired by Yelp, and he saw the value in the technology, but he didn't change his old school mindset in order to really get the value out of it. And this is what we see sometimes as people move from tabular databases to document databases. They see the value of document databases and they're inspired by the technology, but they bring with them their old mindsets so they don't get the full value of document databases. Now, I don't want this to happen to you. I want to see you be really successful as you work with document databases. So before we dive in, let me introduce myself. My name is Lauren Schaefer, and I took a database course in college that was all about best practices for relational databases. I began my career at IBM, where I spent 8 years as a software engineer. For a lot of that time, I used DB2. Toward the end of my time there, my team started getting flexibility in what database we wanted to use, so I started trying out NoSQL databases. To be honest, I didn't really get the hype. Without a doubt, NoSQL databases were easy to get started using. But I brought with me my relational database mindset, so I kept thinking about my data in rows and columns, even though I wasn't using rows and columns anymore. It worked, but it wasn't great. I joined MongoDB about 1.5 years ago, and I've worked through the process of changing my mindset and how I think about storing data. And I'm so happy I did because it's really easy to work with data in the apps that I build now. So today I'm going to share with you what I've learned as I've gone on the journey of moving from tables to documents. I'd love to connect with you on social. You can find me on both Twitter and TikTok with the handle Lauren_Schaefer. I don't really know what I'm doing on TikTok, but I'm having a lot of fun doing it, so I hope to see you there. If you'd like to get a copy of the slides, you can find the link pinned to the top of my Twitter page. It'll probably be pinned for another day or so, and then honestly, another TikTok will probably be pinned to the top of my profile page. All right, anyway, today we're going to be talking about moving from tables to documents. Now, when I say tables, I mean a tabular or relational database. For example, you might have experience using MySQL or Oracle. We'll dive into what document databases are in just a few minutes. So if you're here, I'm going to assume you have experience with relational databases and you have minimal to no experience with document databases. So today we're going to go on a mental journey from tables to documents. How are we going to do that? Well, I'm going to kick things off by mapping the terms and concepts you're familiar with in tabular databases to similar terms and concepts in document databases. Then I'll talk about the 4 major advantages of document databases. And finally, we'll wrap up with 3 key ways you need to change your mindset when you move from tables to documents. So let's jump right in with terms and concepts. Let's talk about documents. No, I'm not talking about Word documents. I'm talking about JSON documents. JSON stands for JavaScript Object Notation. If you've used any of the C family of programming languages, such as like C, C Sharp, Go, Java, JavaScript, PHP, or Python, documents will probably feel pretty comfortable to you. Documents typically store information about one object, as well as any information related to that object. Every document begins and ends with curly braces. Inside of those curly braces are field value pairs. Now, the great thing about documents is that they can be incredibly rich. Values can be a variety of types, including strings, numbers, arrays, dates, timestamps, or even objects. So you can have objects within a document. You'll see what that looks like in just a moment. Now, when people talk about document databases, they'll often use the term non-relational. But that doesn't mean document databases don't store relationships. That was a double negative, stick with me. Document databases store relationships really well. It's just different than the way relational databases do. Let's walk through an example of how you would model the same data in a relational tabular database versus a document database. So let's say we need to store information about a user named Leslie. Let's begin with their contact information. In a relational database, we'll create a table named users. We can create columns for each piece of contact information we need to store, things like first name, last name, cell phone, number, and city. To ensure we have a unique way to identify each row, we'll include an ID column. Now let's store that same information in a document. We can create a new document for Leslie where we'll add field value pairs for each piece of contact information we need to store. So as you can see, we have field value pairs for first name, last name, cell, and city. We'll use _ID to uniquely identify each document. We'll store this document in a collection named users. Now that we've stored Leslie's contact information, let's store the coordinates of her current location. When using a relational database, we'll need to split the latitude and longitude between two columns. Document databases support arrays, so we can store the latitude and longitude together in a single field. We'll call that field location. So now we're successfully storing Leslie's contact information and current location. Now let's store her hobbies. When using a relational database, we could choose to add more columns to the users table. However, since a single user could have many hobbies, meaning we need to represent a one-to-many relationship, we're more likely to create a separate table just for hobbies. Each row in the table will contain information about one hobby for one user. When we need to retrieve Leslie's hobbies, we'll join the users table and our new hobbies table. Since document databases support arrays, we can simply add a new field named hobbies to our existing document for Leslie. The array can contain as many or as few hobbies as we need. When we need to retrieve Leslie's hobbies, we don't need to do an expensive join to bring that data together. We can simply go and retrieve her document in the user's collection. Let's say we also need to store Leslie's job history. Just as we did with hobbies, we're likely to create a separate table just for job history information. Each row in the table will contain information about one job for one user. So far, we've used arrays to store geolocation data and a list of strings. Arrays can contain values of any type, including objects. So let's create an object for each job Leslie has held and store those objects in an array. As you can see, we have a job history field that stores an array. Inside of that array, we have an object for when she was the deputy director, an object for when she was a city councilor, and an object for when she was director of the National Park Service's Midwest branch. So now that we've decided how we'll store information about our users in both tables and documents, let's store information about Ron. Ron will have almost all the same information as Leslie. However, since Ron does his best to stay off the grid, he will not be storing his location in the system. So let's begin by examining how we would store Ron's information in the same tables that we used for Leslie's. When using a relational database, we are required to input a value for every cell in the table. We will represent Ron's lack of location data with null. The problem with using null is that it's unclear whether the data does not exist or if the data is just unknown, so many people discourage the use of null. In document databases, we have the option of representing Ron's lack of location data in two ways. We can omit the location field from the document, or we can set the location to null. Best practices suggest that we omit the location field to save space. You can choose, though, if you want omitted fields and fields set to null to represent different things in your application. Ron has some hobbies and job history, so we'll add his information to those tables. And we can add that information to his document as well. The structure of Ron's document looks pretty similar to Leslie's. So let's say we're feeling pretty good about our data models and we decide to launch our apps using them. Then we discover we need to store information about a new user, Lauren Burhug. She's a 4th grade student who Ron teaches about government. We need to store a lot of the same information about Lauren as we did with Leslie and Ron, things like her first name, last name, city, and hobbies. However, Lauren doesn't have a cell phone, location data, or job history. We also discover that we need to store a new piece of information, her school. So let's begin by storing Lauren's information in the tables as they already exist. We can create a new document for Lauren and include the data we have for her in it. Now let's talk about how to store information about Lauren's school in our tables. We've got two options. We can choose to add a column to the existing users table, or we can create a new table named schools. So let's say we choose to add a column named school to the users table. Depending on our access rights to the database, we may need to talk to the DBA and convince them to add the column. Maybe we have to do a little begging to get our DBA to add the column. Maybe we have to do a little bribing. Maybe we bring our DBA their favorite donut. Or maybe we bring our manager along to pressure the DBA into agreeing. If our DBA agrees, the database will likely need to be taken down, the school column will need to be added, null values will be stored in every row in the users table where a user does not have a school, and the database will need to be brought back up. It's doable, it can just be a little painful. Now let's talk about how to store Lauren's school in documents. We can simply add a new field named school to Lauren's document. We do not need to make any modifications to Leslie's document or Ron's document when we add the new school field to Lauren's document. Document databases have a flexible schema, so every document in a collection does not need to have the same fields. Now, for those of you with years of experience using relational databases, you might be starting to panic at the idea of a flexible schema. I mean, I know I started to panic a little when I saw this idea. Don't panic. This flexibility can be hugely valuable as your application's requirements evolve and change. Also, some document databases provide schema validation, so you can lock down your schema as much or as little as you'd like when you're ready. All right, so now that we're starting to get the idea of how tables and documents are similar and different, let's do some explicit term mapping. On the left side of the screen, you'll see tabular or relational database terms, and on the right side of the screen, you'll see document database terms. So first up, we saw this a bit in our example, a row maps to a document. Or depending on how you've normalized your data, rows from multiple tables could map to a single document. A column maps roughly to a field. In a relational database, groups of rows are stored in tables. In a document database, groups of documents are stored in collections. So tables map to collections. Now, the next few terms will probably feel pretty comfortable to those of you with relational database backgrounds, as the terminology is basically the same between the two. Just like you store groups of tables in a relational database, you store groups of collections in a document database. Indexes are fairly similar between the two. Indexes help speed up your read queries. Views are pretty similar in both. Now, there are a few different ways to handle joins in document databases. The general recommendation is that if you have related information that you would put in a separate table in a relational database, you should probably embed that information in a single document when working in a document database. The rule of thumb is that data that is accessed together should be stored together. Let me say that again. Data that is accessed together should be stored together. So if you'll be frequently accessing information together that you would have put in separate tables, you should likely just embed it in a document. Now, depending on the document database you're using, there are other options for joins as well. Some databases support references between the documents, similar to how you would use a foreign key. Some databases also have special operations to support a left outer join. These options for joins get specific to the database you're using, so I'm not going to go any deeper into that today. All right, finally, let's talk about ACID transactions. Transactions group database operations together so they either all succeed or none succeed. Now, if you did some research online about relational databases versus document databases before coming here today, you probably saw something about document databases not supporting transactions as a major drawback. If you care about data integrity, and really, who doesn't, that's a pretty scary sounding drawback. Some document databases support ACID transactions, while others do not. In relational databases, we call these multi-record ACID transactions. In document databases, we call these multi-document ACID transactions. However, when you model your data for document databases, you'll find that most of the time you don't actually need to use a transaction. I'll explain why that is at the end of the presentation. So don't get freaked out if you're looking at drawbacks of document databases and see no transactions listed. Some document databases support transactions, but chances are good that either way, you won't actually need them. All right, so to wrap up this section, I created this term mapping summary for you. It's way too much information for you to read now, but you can take a screenshot, maybe you want to tweet it, maybe you want to print it and hang it up at your desk, whatever you need to do. But before we go on, I want you to internalize the first three term mappings. A row maps to a document, a column maps to a field, and a table maps to a collection. All right, I'll give you just a moment if you want to grab a screenshot. All right, so now that we have an understanding of the terms and concepts, let's talk about the four major advantages of document databases. Let's jump back to Ron for a moment. Ron loves his typewriter, and unless you convince him otherwise, there is no way he's going to change his mindset. Maybe that's you. Maybe you've been successful with relational databases. You're comfortable with them. They aren't always the easiest, but you've learned how to get the job done. So let's answer the question, is it really worth changing your mindset from tables to documents? I'm going to walk you through 4 advantages to using document databases, and these are in no particular order. Let's begin by talking about scaling. Let's say Ron has an app where he sells the chairs he makes in his workshop. He's using a relational database behind the scenes. When one of Ron's chairs is nominated for an award from the Indiana Fine Woodworking Association, orders start pouring in. He needs to scale his database. Now, typically, relational databases scale vertically. When his database becomes too big for his server, he has to migrate it to a larger server. When Ron's chair appears in Blush magazine, his chairs go viral and he needs to migrate to an even larger server. Now, there are a few key problems with vertical scaling. Large servers tend to be more expensive than 2 smaller servers with the same total capacity. Large servers may not be available due to cost limitations, cloud provider limitations, or technology limitations. And migrating to a larger server may require application downtime. All right, let's take another example. Let's say Tom has an app for his restaurant called Tom's Bistro. He uses a document database behind the scenes. After a feature in the Pawnee Journal, his restaurant surges in popularity and he needs more space for his database. Since Tom is using a document database, he has the flexibility to scale horizontally through sharding. Now, sharding is a method for distributing data across multiple servers. When his database exceeds the capacity of its current server, he can begin sharding and split it over 2 servers. When the shelter-in-place orders hit Pawnee and everyone has to order food online, Tom can continue to add more servers. The advantage is that these new servers don't need to be big, expensive machines. They can be cheaper commodity hardware. Plus, no downtime is required. So with document databases, you can scale cheaper. As the size of your database grows, you can scale horizontally. Your queries will typically be faster with document databases. Let's examine why. Even in our simple example we worked through earlier, where we modeled Leslie's data in both tables and documents, we saw that her information was spread across 3 tables. Whenever we want to query for Leslie's information, we're going to need to join 3 different tables together. In these 3 small tables, the join is going to be very fast. However, as the tables grow and our queries become more complex, joining those tables together becomes very expensive. Now, recall our rule of thumb when modeling data in document databases. Data that is accessed together should be stored together. When you follow this rule of thumb, most queries will not require you to join any data together. So continuing with our earlier example, if we want to retrieve Leslie's information from a document database, we can simply query for a single document in the user's collection. As a result, our query will be very fast. As our collections grow larger, we don't have to worry about our queries slowing down as long as we are using indexes and continuing to follow that rule of thumb. Data that is accessed together should be stored together. All right, requirements change. It's a regular part of the software development lifecycle. Sometimes the changes are simple and require only a few tweaks to the user interface, but sometimes changes go all the way down to the database. Let's think back to our earlier example where we needed to update our database to store information about Lauren's school. To add a new school column in our relational database, we're going to have to alter the users table. Executing the alter table command could take a couple of hours depending on how much data is in the table. The performance of our application could be decreased while the table is being altered, and we may need to schedule downtime for our application. Now let's examine how we can do something similar in document databases. When our requirements change and we need to begin storing the name of a user's school in a user document, we can simply begin doing so. We can choose if and when to update existing documents in the collection. If we'd implemented schema validation, we would have the option of applying the validation to all inserts and updates or only to inserts and updates to documents that already meet the schema requirements. We would also have the choice of throwing an error or a warning if a validation rule is violated. So with document databases, you can easily change the shape of your data as your app evolves. All right, finally, you can program faster. Now, to be honest with you, this advantage is one of the biggest surprises to me. I figured that it really didn't matter what you used as your backend database. The code that interacts with it would be basically the same. I was wrong. Documents map to data structures in most popular programming languages. This sounds like such a simple thing, but it makes a huge difference when you're writing code. A friend encouraged me to test this out, so I did. I implemented the code to retrieve and update user profile information. Now, my code has some simplifications in it to enable me to focus on the interactions with the database rather than the user interface. I also limited the user profile information to just contact information and hobbies. So let's walk through my implementation. I used MySQL for my relational database and MongoDB as my document database. I wrote the code in Python, but don't worry if you're not familiar with Python. I'm going to walk you through it step by step. The concepts will be applicable no matter what your programming language of choice is. All All right, so before I show you the code, let's do a quick refresh of the data we're going to retrieve and update. On the left, we have a table for users and a table for hobbies. On the right, we have a document for our user that contains both contact information and hobbies. So let's begin with that typical top of the file stuff. We'll import what we need, connect to the database, and declare our variables. I'm going to simplify things by hard coding the user ID of the user whose profile we will be retrieving, rather than pulling it dynamically from the front end code. Now, if we look at the MongoDB code, it's basically the same: importing, connecting, and setting the user ID variable. So now that we have our database connections ready, let's use them to retrieve our user profile information. Since the user profile information is spread across the users table and the hobbies table, we'll need to join them in our query. So we'll say, select everything from the users left join hobbies. We can use prepared statements to ensure our data stays safe. So we'll set the values in our prepared statement, execute the query, fetch our result. Because we joined the users and the hobbies tables, we have a result for each hobby this user has. So to retrieve all the hobbies, we need to iterate the cursor. So we'll append each hobby to a new hobbies array and then add the hobbies array to our user dictionary. All right, now let's implement that same functionality for MongoDB. Since we stored all the user profile information in the user document, we don't need to do any joins. We can simply retrieve a single document in our collection. So here's where that big advantage that documents map to data structures in most popular programming languages comes in. I don't have to do any work to get my data into an easy to work with Python dictionary. I get all the results in a Python dictionary automatically, and I don't need to manipulate the results. I'm done. So our user dictionaries are now pretty similar in both pieces of code. The one exception is how we're storing our location data, but this is a pretty minor difference. Now that we've retrieved the user's profile information, we'd likely send that information back up the stack to the front-end UI code. When Leslie views her profile information in our application, she may discover that she needs to update her profile. So the front-end UI code would then send that updated information in a Python dictionary back down to the stack to the Python files we've been writing. So to simulate Leslie updating her profile information, I'm just going to manually update the Python dictionary myself for both MySQL and MongoDB. These updates are basically the same with the exception of how the location data is being stored. Not really a big deal. So now that our user dictionary is updated, let's push that updated information to our databases. So let's begin with MySQL. First, we need to update the information that is stored in the users table. We'll say update users, set first name equal to this string, last name equal to this string, cell equal to this string, all the way through. Then we'll set the values of all of those strings. Is this complicated? No, not really. Is this error prone? Yeah, kinda. You have to make sure you get every string in just the right spot. And to be honest with you, I did not unit test this code. I know I'm a bad developer, but it's possible I've made a mistake without even realizing it. Now, this is a pretty simple example, so I probably got it right, but SQL queries can get really long, so you can imagine this getting much more complicated. All right, next we need to update our hobbies. Now, for simplicity, I'll delete any existing hobbies in the hobbies table for this user, and then I'm just going to insert the new hobbies into the hobbies table. Now let's update the user profile information in MongoDB. Since the user's profile information is stored in a single document, we only have to do a single update. Once again, we will benefit from documents mapping to data structures in most popular programming languages. We can send our user Python dictionary when we call update one, which significantly simplifies our code. So in this example, we wrote 27 lines of code to interact with our data in MySQL and 2 lines of code to interact with our data in MongoDB. Now, fewer lines of code is not always indicative of better code. But in this case, we can probably agree that fewer lines of code will likely lead to easier maintenance and fewer bugs. This example was relatively simple with small queries. Imagine how much bigger the difference would be for larger, more complex queries. Documents mapping to data structures in most popular programming languages can be a huge advantage in terms of time to write, debug, and maintain code. All right, so is it worth changing your mindset and learning how to work with a document database? I think so. With a document database, you can scale cheaper, query faster, pivot easier, and program faster. All right, let's move on to our final section. Let's talk about the 3 key ways to change your mindset as you move from tables to documents. People who pick up a document database and try to use it as a relational database are the ones who typically struggle and fail. You can't keep doing things in the same way. So let's talk about the 3 key ways to change your mindset. First up, embrace document diversity. Let's think back to when we modeled documents for Leslie, Ron, and Lauren. We saw that not all documents in a collection need to have the same fields. Now, for those of us with relational database backgrounds, this is going to feel really uncomfortable and probably a little odd at first. I promise it will be okay. Embrace document diversity. It gives us so much flexibility and power to model our data. In fact, there's a schema design pattern that specifically focuses on documents not having the same fields. It's called the polymorphic pattern. We use the polymorphic pattern when documents in a collection are of similar, but not identical structures. Oh, not sure how I did that. Okay, let's take a look at an example that builds on the polymorphic pattern. Let's say we decided to keep a list of each user's social media followers inside of each user document. Lauren and Leslie don't have very many followers, so we could easily list their followers in their documents. For example, Lauren's document might look something like this. At the bottom of her document, we can see a list of her followers, Brandon, Wesley, and Sierra. This approach would likely work for most of our users. However, since Ron built a chair that appeared in the very popular Blush magazine, Ron has millions of followers. If we try to list all of his followers in his user document, it may exceed a document size limit. So the question arises, do we want to optimize our schema to design for the typical use case, where a user has a few hundred followers, or the outlier use case, where a user has millions of followers? We can actually utilize the outlier schema design pattern to solve this problem. The outlier pattern allows us to model our data for the typical use case, but still handle those outlier use cases. We can begin modeling Ron's document just like Lauren's and include a list of followers. When we begin to approach the document size limit, we can add a new has extras field to Ron's document. And this field could be named anything we'd like. Then we can create a new document where we will store the rest of Ron's followers. If Ron continues to gain more followers, we could create another overflow document for him. So the great thing about the outlier pattern is that we're optimizing for the typical use case, but we have the flexibility to handle outliers. So embrace document diversity. Resist the urge to force all of your documents to have identical structures just because it's what you've always done. All right, second way to change your mindset. Data that is accessed together should be stored together. Maybe you've heard over and over again that you should normalize your data. Why is that? Well, historically, there are a couple different reasons for this. One is that when relational databases became popular, disk space was extremely expensive. Financially, it made sense to reduce data duplication and save disk space. As you can see from this chart, and you know from buying flash drives, if people even buy those anymore, the price of storage has dramatically decreased. Our phones, tablets, laptops, and flash drives have more storage capacity today than they did even 5 to 10 years ago for a fraction of the cost. When was the last time you deleted a photo? I can't remember when I did. I even keep those really horribly unflattering photos. And I currently back up all of my photos on 2 external hard drives and multiple cloud services. Storage is so cheap. Storage has become so cheap that we've actually seen a shift in the cost of software development. 30 to 40 years ago, storage was a huge cost in software development, and developers were relatively cheap. Today, the costs have flipped. Storage is a small cost of software development, and developers are expensive. I promise there is a pink bar over there in 2017. It's just so small you can't see it. Instead of optimizing for storage, we need to optimize for developers' time and productivity. Now, as a developer, I like this shift. I want to be able to focus on implementing business logic and iterating quickly. Those are the things that matter to the business and move developers' careers forward. I don't want to be dragged down by data storage specifics. Let's think back to that earlier example where I coded retrieving and updating a user's profile information. Even in that simple example, I was able to write fewer lines of code and move quicker when I used a document database. So leverage embedding. Consider how you can use objects, arrays, and arrays of objects to store your data together. Resist the temptation to break up your data. Data that is accessed together should be stored together. If you end up repeating data in your database, that's okay, especially if you won't be updating it very often. All right, last way to change your mindset. Tread carefully with transactions. Some document databases support ACID transactions while others don't. But here's the thing. If you're modeling your data for the document model, you're probably not going to need a transaction. In fact, start over. Relying on transactions is a bad design smell. Why? Well, this really builds on the first 2 points in this section. First, not all documents need to have the same fields. Perhaps you're breaking up data between multiple collections because it's not all of identical structure. If that's the only reason you've broken the data up, you can probably just put it back together in a single collection. Second, data that is accessed together should be stored together. If you're following this principle, you won't need to use transactions. Some use cases call for transactions. Most do not. If you find yourself frequently using transactions, take a look at your data model and consider if you need to restructure it. All right, so to summarize the 3 key ways to change your mindset. Embrace document diversity. Data that is accessed together should be stored together. Tread carefully with transactions. All right, let's wrap up this presentation. So today we went on a mental journey from tables to documents. We began by mapping terms and concepts from tables to documents. The 3 that are the most important are those first 3. Rows mapped to documents, columns mapped to fields, and tables mapped to collections. Then we talked about the 4 major advantages of documents. You can scale cheaper because you can scale horizontally. You can query faster because you aren't having to do expensive joins to bring your data together. You can pivot easier because you have a flexible schema. And finally, you can program faster because documents map to objects in most popular programming languages. And then we wrapped things up with the 3 key ways you need to change your mindset. First, embrace document diversity. Not all of your documents need to be the same shape, and that's perfectly okay. Second, data that is accessed together should be stored together. And third, tread carefully with transactions. Relying on transactions when you're using a document database is a bad design smell. So if I had to sum up this presentation in one idea, I would say this. Don't be Ron Swanson in this particular case, because Ron Swanson is amazing in so many other ways, but don't be Ron Swanson. Change your mindset and get the full value of document databases. At the end of this presentation, I've included a list of additional resources. The top resource listed here is a blog series I wrote that has content very similar to what I presented today, but it's specific to MongoDB. So later, if you want to reference the material I covered, that's a great place to start. One of the best ways to, can I do one or two more slides? Okay, one of the best ways to learn a new technology is by trying it out. MongoDB Atlas is a fully managed document database service. It has a perpetually free tier that is great for learning if you'd like to try it out. So if you hop back a slide, I have a link to a quick start blog series that will walk you through trying it out. If you'd like to get a copy of my slides, check out my Twitter page. I'm Lauren_Schaefer. And I have one more announcement for you. Racial justice is an issue that is important to me personally, as well as to MongoDB. MongoDB is currently matching funds that are donated to organizations that were selected by our Underrepresented People of Color Affinity Group. If you'd like to have your donation matched, visit mongodbforjustice.mongodb.events. I would love to hear any feedback you have about this session, so please take a moment to fill out the session survey in Loudswarm. All right, and with that, let's open the floor for questions. Do we have any questions in the Q&A or Slack?
Hey, Lauren, thanks for the session. You made it like so simple. I think we have a few questions that already popped up and questions are coming on the way.
Awesome.
So we'll go with the first question from Wiz. How does this scale in a very large star schema?
How does it scale? So we talked about a bit about horizontal scaling, and that is through the process of sharding. So basically you can split a collection on a particular, we call them a shard key, and your collection can be split among multiple servers. And so that's a really nice advantage, is being able to just add another server when you need it and you're good to go. What's our next question?
Our next question is from Fitz. Do you have any rule of thumb for like when to choose between the relational versus document, and if there are any use cases that doesn't apply for the documents?
That is a great question. So we talk about MongoDB, which is a document database. We talk about it as being a general purpose database. So for most use cases where you would pick a relational database, a document database is another great choice. So sometimes people think, oh, it's just great for these niche use cases, but document databases are actually really great for a variety of use cases. So as I mentioned earlier, sometimes people throw out the term like relational databases, and then they think, document databases are non-relational. And so if you have relationships, maybe you should go with a relational database. And that's really not the case. Document databases store relationships. They just do it in a different way. And a lot of people find the way that document databases store relationships to be more intuitive, because you aren't having to break the data up. All that being said, there are a few niche use cases where you probably don't want to select a document database. And I can pull up, there's a white paper one of my colleagues wrote that goes through use cases. It's specifically when you should and should not use a document database. I think one of them is like if you need to use something similar to like when you're graphing things. So if you're going to go and you're going to need to search for shortest path, you probably want to use a graph database that's specifically designed for something like that. So it's very niche edge cases where you would probably want to use a specific database. But in general, document databases are a really great general purpose database. Thanks for asking.
Okay, thanks. Thanks, Lauren. The next question from Srinivasan. If I need to find out how many users have book scrapping as a hobby, how would I do that in the document DB? Will it be faster than the relational database?
All right, I'm going to jump back to my slides so we can look at how we modeled that. So we're all on the same page. And can you repeat that question for me one more time?
Yes, sure. So the question is, if I need to find out how many users have book scrapping as a hobby, how would I do that in the document DB?
Good question. So if we're looking at how many people have this hobby, we would say we would query for have hobbies. I'm sorry, I don't know if you can see my cursor. We would query for how many people have hobbies, or I'm sorry, we would query for documents that have woodworking in hobbies. We have a nice in operator. And then I'm trying to remember, I know with the aggregation pipeline, we have a count operator. Um, I'm going to talk specifically about MongoDB because it's the implementation I know best. In MongoDB, we have an option to use the aggregation pipeline. And it's super helpful for doing any sort of analytical queries. And you can create multiple stages and manipulate your data. So one of the operators in the aggregation pipeline is count. And so we could just do a match, find the documents that have woodworking, and then we could use that count operator. Do we have any other
Okay.
questions?
Yep. So we'll move to the next question. From Ro, how do you handle parsing reports, Excels or PDF that are similar but have a minor formatting differences?
So let me make sure I understand the question. So how do you handle parsing um, different types
Excel
of
or PDF reports.
PDF reports? That is a tricky one. Let me think real. I've not done that myself, so let me take a minute and think about it. So it sounds like what you want to do is you want to pull the data in and you want to parse it, and it's of different formats, and you want to put it into a database. So there are a couple different options. One would be to, write a script that's going to go in and pull the data out, and you kind of have to know what's going on there. Another option is I'm going to speak to MongoDB's implementation again because it's what I know best. MongoDB Atlas has a data lake that will allow you to query for information that's in different sources like PDFs or S3 buckets or that sort of thing. I know it exists. I know at a high level that that's how it works, but I can't get any more into the specifics. But I can definitely look it up and drop some links in after the session.
Okay. We have a follow-up question from Viz who asked about the large star schema. So the question is like, can the document get extremely large when there is many to many relationships?
Yes, the document can get extremely large. So some document databases have really small size limits. I think some of them have 400 kilobytes. MongoDB is 16 megabytes, and I think there's another one that's double that, maybe 32 megabytes. So it depends on the document database you're using, what your document size limit is. And there are some things you want to keep in mind. So when we talk about MongoDB schema design patterns, and I just wrote a series and a video series about MongoDB schema design anti-patterns. And one of the things we talk about in there is we don't want to have massive unbounded arrays. And you don't want to have those because your document can get too big, your index performance can go down and that sort of thing. So you want to make sure data that is accessed together is stored together, and not necessarily data that is related to each other is stored together. And the distinction there is you want to store your information the way that your application uses it. So if you've got information that's kind of related, but it's not being accessed together in your application, you don't want to store it together. You want to keep your documents focused on being stored the way that your application is using it. Because yeah, you don't want to have a massive, huge document being passed back and forth if you don't really need all that information. Good question.
Okay. There is a clarification from Ro who asked about parsing the PDF reports that their use case is mostly to aggregate data that is coming from multiple PDF or Excels, which might be similar but have little formatting difference. But you can like answer that better as you said.
Yeah, I think I'd probably have to sit down and look at it with you. Unfortunately, I don't think I've got any generic advice other than, yeah, if it's not formatted, if you just want to pull it in and dump it into a database, it's totally fine that they're formatted differently, and then your application can handle querying it appropriately. Or if you want the information to be structured the same, the way you import it, you're going to have to structure it the same. So Um, yeah, I'm sorry, I don't have a great answer for that question.
Thanks. Okay, there is one more question from Fitz. Python is great, but for more of a data analyst role, is there something like SQL for the document DBs that can be used?
Yes, definitely. So actually, I think I jumped ahead in the question. Can you ask the question again?
So question is like, is there something like SQL for document DBs other than Python, like doing it in Python?
Yeah, so I'm going to speak specifically to MongoDB again. So MongoDB has drivers for most popular programming languages. So programming languages like Java, Node, Go, Rust. I think we've got maybe C Sharp, a variety of languages we've got drivers for. So that makes it very simple. If you're trying to compare strictly the query language, so in relational databases, we use SQL. Um, for the example of MongoDB, we have MongoDB's query language. And so you can use that MongoDB query language to query in the Mongo, from the command line using the shell. You can use that from your application code. So you've got a lot of flexibility there.
Okay, we don't have any more questions at this moment.
Awesome. Thank you all so much for all those questions. If I did not fully answer your question, if you want to drop it in the Slack, I will try to follow up with some links on things like data lake and the dollar count and all that. So let me know and I will, because everything is now a blur. When you start talking, everything becomes a blur. So I'd be happy to provide more information.
Sure. Thank you so much, Lauren. This was like a wonderful session and a lot of questions. So
Thank
wonderful.
you. Have a great rest of your afternoon, everybody. Bye.